Next speaker, I said before, it's a little bit mixed up right now, but we have next have Gloria Zhao. She's a Bitcoin Core developer, and she's going to talk about censorship and DOS attacks, an introduction to mempool policy. So, very excited to have you. Here she is. Give a warm welcome to Gloria.
Hello, can you hear me now? They can hear me? You can hear me, okay. Perfect. Well, thank you so much for having me. It's a pleasure to be here on the screen. I am in London, but I just got COVID 2 days ago, so inconveniently, I guess I'm doing this virtually. So I'm gonna share my screen, right? Da-da-da. Can you see this? I just realized I have no way of getting feedback from you guys. I can hear merch though. Okay, so I'm gonna assume you can see my screen. As mentioned, I have the pleasure of working on Bitcoin Core full-time. And I focus most of my time on mempool policy and transaction relay because I find it to be one of the most interesting parts of Bitcoin Core. And hopefully today I can convince you of that as well. Oh, here we go. Okay. So what makes Bitcoin interesting to many of us is anyone can send anyone money however they want, regardless of where they live, which country they live in, what political beliefs they have and express. And that's what we find beautiful ideologically. But technologically, this presents a engineering challenge. We have this idea of permissionless, and what that often translates to is we're trying to make Bitcoin for the lay user, right? And so we cannot create requirements such as, oh, to run a validator, you need to spend $2,000 a month on an AWS instance, or you need 256 gigs of RAM, or you need the latest version of macOS installed on your computer, right? These are not acceptable to us. In fact, the benchmark that I like to use is you should be able to run a full node on a Raspberry Pi. And on the other hand, when you talk about permissionless and you say, okay, anyone should be able to participate in the Bitcoin network, regardless of possible censorship from their government or whatever, we should expect that there are going to be people trying to censor, people trying to DOS on the network. So it's really the Wild West when we're talking about peer-to-peer. Okay, so as you all know, Bitcoin network is a distributed system that might look something like this, as in lots of stuff and you don't really know what's going on. So anyone should be able to run a Bitcoin node and join the network, whether that's Bitcoin D running on your laptop, a Raspberry Pi that you use with Umbrel, for example, or some kind of exchange that is running a cloud server that has Bitcoin nodes, and many people's smartphones using their exchange app are connecting to that node. Or of course there are miners. And the goal is anyone can run their Bitcoin node, connect to the Bitcoin network, and broadcast, and hopefully their transactions will propagate to these miners that will include those transactions in a block. And the key is that everyone looks more or less the same on the Bitcoin network. Okay. Another thing that you may or may not be familiar with is usually how this works is the nodes participating in transaction relay will keep a kind of cache called a mempool that has all those unconfirmed transactions that they have received. And typically this cache is 300 megabytes, so very small. And of course, you want to use that space very wisely. And so obviously we will validate those transactions when we receive them before we submit them to the mempool. Okay, so as I hinted at before, one side effect of having a permissionless network is your peer may very well be an attacker. And in fact, we cannot assume that peers are not attackers. We cannot even assume that we'll be able to have a reputation system or know the identity of someone so that we can prosecute them. We really need to have like as much vigilance as possible when we're designing our mempool validation logic. So some examples of what your peer could be trying to do is trying to DOS you. So trying to exhaust your CPU, validating a bunch of signatures that are going to be useless in the end, or maybe get you into some kind of logic that they found by looking at the Bitcoin Core code, that there's some infinite loop they can make you go into. Or maybe they can cause an out of memory in your mempool. These are all things that we're very, very cognizant of when we're trying to design safe mempool logic. Maybe they are trying to clog up network traffic in order to sabotage or censor somebody else's transaction or simply grief the network. They could be trying to fill mempools with garbage or flush those mempools to make them less useful to, let's say they're a miner and they're being competitive and they want to either stall other miners so that they can get a head start or they can collect more fees or whatever it is. There are plenty of attacks that we know and don't know about that are possible. So how do we protect ourselves from DOS? Well, one of the many techniques we use is during mempool validation, we'll fail fast and we'll reject things that we just don't want to be spending our resources on. So one thing you might have heard of is a standard transaction, standard meaning passing mempool policy, or the Bitcoin Core default mempool policy, cannot be more than 100,000 virtual bytes. The typical payment is going to be less than 1,000, to be honest. So this is a pretty, I would say, reasonable restriction to have. Another is we don't want to create these giant chains or descendant sets for transactions. So for example, on the graph on the right, let's say you were to be able to put this entire or more transaction chains or trees or whatever this is called into people's mempools, and then you're able to replace that transaction either with a block transaction or or an RBF or something. And then that took up like 80% of their mempools, and then you've managed to flush out and make people's mempools much less useful. So that is another example of something that we use to limit the amount of resources that a peer-to-peer peer can demand of our resources. And then, of course, we want to limit the amount of signature verifications that someone requires us to do, since that is very computationally expensive. And the best example, I think, of mempool policy is we run context-free sheet checks first, and we save things like signature verification for last. And we also cache a lot of things. So these are some examples of policies for protection against DOS. In general, I think now is a good time to define what mempool policy is. It is a set of local validation rules in addition to consensus, so not including the consensus rules and on top of the consensus rules, which unconfirmed transactions must pass to be accepted to this particular node's mempool. Again, these are local. They're specific to a node. They can be configured by the user, and nobody is forcing anyone to run any kind of policy. And another thing I want to highlight is this is only applied to unconfirmed transactions. This has nothing to do, or has very little to do, with consensus. Okay. So we might think of policy on this spectrum. I'm going to say that this is a flawed diagram later, but we might start off by thinking of policy on this spectrum, where on the one hand, you can imagine a hypothetical world where we have infinite resources. We're able to freeze time whenever we receive a transaction. And maybe in this case, we want to accept all consensus valid transactions, maybe. And on the other side of this spectrum is a perfectly defensive mempool policy where we only validate transactions if it's from someone that we know, like the real identity of, or has registered somehow with our node. And of course, this case, you are really no better than a bank, and this isn't really fulfilling our permissionless ideas for the Bitcoin network. Okay, but this is flawed, and I'm going to talk about why. So on the one hand, we were thinking about the ideal mempool where we had infinite resources, right? Would it, even if we had a class of users with infinite mempool resources, would we want to publish software for them such that they would accept all currently valid, consensus valid transactions? So now this is where I would look into the audience and ask you to raise your hands. But since I can't see you, just turn to your neighbor and say whether or not you think this is a good idea. So the answer is no. As you might imagine, let's say all the transactions we might receive on the peer-to-peer network, some of them might be invalid, right? And some of them might be consensus valid. But we do hope to be able to upgrade consensus rules in the future. So as you know, in a soft fork, the space of consensus valid transactions shrinks. And not everyone upgrades their nodes at the exact same time during a consensus change. And this is a feature, not a bug. We want to be able to tolerate that. And we did have a soft fork recently. Thank you, Timo, for allowing me to use this tweet. We did notice that miners, not necessarily all of them, had upgraded their nodes right when Taproot activated, right? And we knew this because they weren't mining Taproot transactions. And so what would have happened if their mempool policy was accepting version 1 witnesses via the existing consensus rules before the soft fork, before we had assigned any meaning to that? Well, maybe they would have just accepted them into their mempools, and if they had mined them, that would have been pretty bad, since you would have a network split where some people are enforcing Taproot and some people are not. Now, it's okay as long as the majority hash rate is on the most work chain. But we definitely want to prevent miners from being able to mine these possibly future invalid transactions if they don't upgrade on time. So part of our policy rules, at least in Bitcoin Core, is we will reject anything that we might upgrade in the future. So things like upgradable NOPs, witness versions greater than 1. In the past, before Taproot, we also discouraged 1. And versions that are greater than what we currently use. And this is so that we can upgrade more safely in softworks. So that's why this side of the spectrum doesn't make any sense. And what about the other side? So let's say we were perfectly defensive, and we had all these DOS protections, which we do. Is there any way that we can accidentally, inadvertently harm other users with our rules? This is a very poorly phrased question, but yes, the answer is yes. Previously, I talked about the descendant size limit, right? So this is intended to protect us from DOS, so that we don't have like a giant chain that can eventually be flushed out. Or, in a reorg, it might make things very difficult or computationally expensive, to be updating all those entries. We want to be able to limit that. However, in the Wild West, there are contracting protocols where there are transactions where outputs are shared by different counterparties, or not shared, but owned by different counterparties. And so thus this transaction is shared between them. And maybe we want both counterparties to be able to CPFP fee bump this transaction. Or, they both have a UTXO on there, so they should be able to spend from it, right? And such is the case with Lightning and their anchor outputs. However, when the anchor outputs idea was proposed, this attack came up almost immediately, where they said, okay, what if one of the counterparties just dominates the descendant limit? Then the other party cannot fee bump this transaction anymore. This is an example of a pinning attack, which is a type of censorship attack in which the attacker takes advantage of what policies they know mempools to have in order to prevent transactions from being accepted or mined. So in this case, that child for fee bumping would not be accepted. And in other cases, well, actually including this one, you are preventing a transaction that is in the mempool from being mined because you are preventing the user from being able to attach more fees to it. And this is a type of censorship attack where it can be really, really bad for contracting protocols or L2 protocols that rely on being able to broadcast reliably on the peer-to-peer network in order to settle on chain, which is why pinning attacks, at least I think about a lot. Okay. So again, this is one of those things where the interactivity is a little bit limited, but I'm just going to pretend like I can hear you. Let's say you are designing mempool policy or mining policy, mining code, and you're trying to decide between these two transactions as a miner. Okay, which one is better? Obviously, since they're the same size and the one on the left pays twice as many fees, we choose the one on the left, right? Okay. And what if one of the transactions allows you to mine another transaction that spends from one of its UTXOs and has really, really high fees? Okay, well, maybe in this case, we might prefer the one on the right. Depends on how much space we have left in our block template or how much we have left in our mempool, right? But in most cases, maybe you can fit both in the block or both in your mempool, for example. By the way, this is known as child pays for parent, as many of you will know. And the other case is, okay, what if they're conflicting and you really cannot put both of these in the same block? Now you have to make a choice to reject one of them from your mempool. Well, this case is pretty cut and dry as well. The one on the right spends 10 times as many fees. So you probably like that one better. But maybe this decision is a little bit more complicated if you saw the one on the left first and you added a bunch of descendants to it. Or what if you keep seeing like 4,000 transactions between TX1 and TX1 prime, where there's a DOSer that is essentially adding 1 sat more in fees every single time they broadcast it. Well, you have to make a decision on what your policy is in order to be both incentive compatible and DOS protected and not prevent someone from being able to RBF their transaction. Sorry, I just got ahead of myself. But anyway, in these two scenarios, these quizzes or whatever, I was talking about some policies where we are essentially allowing users to be able to add fees to their transactions to make them confirm faster. And this is also very incentive compatible for miners because we're getting them better fees. And for wallet developers, you know these as replace by fee and child pays for parent. Cool. So in conclusion, today we've gone through what mempool policy is, and there are many reasons for why mempool policy exists, not just DOS, but also incentive compatibility, being able to upgrade the network consensus rules in a safe manner, and help prevent censorship attacks, known as pinning attacks. So thank you, and I'm open for questions, even though I can't really hear you.
So if you have questions, maybe come up here and talk into the microphone or to Gloria directly so she can hear you, I think. Yeah? Yeah, come. Just come on up here for this one. You can hear us, right?
Hi, can you hear me?
Yeah, I can hear you.
Oh, we can't hear you.
Oh, we can.
Oh.
Oh, there she is.
Can you hear me now?
If you stand here, she can see you. Like,
Oh, yeah.
I can hear you.
Okay.
I can see
Can you?
your chest.
Okay.
You know.
I'm gonna stand
Yes.
up.
Okay, yeah, no problem.
So a couple of years ago, during the block size wars, there seemed to be a kind of what looked like a successful spam attack. Can you speak about that? What was learned from that, and would a similar thing still be possible?
Sorry, could you be a bit more specific about what the attack was?
During the time of the of the block wars, the fees of Bitcoin rose very highly.
Right.
To so high that it was kind of unusable at some point. And it seemed like, I might be wrong, but it seemed like somebody was spamming it. Am I wrong in that assumption, or?
So I cannot really speak to the intentions of the people that were broadcasting high fee transactions.
Yeah. Maybe I've misunderstood it, but it looked like a spam attack. But if it's a dumb question, that's fine. You can just say it's a dumb question.
Well, I would hope that if people are required to pay a lot of fees. Yeah, okay, Rich can take this question.
I think we're talking about the 2017 winter mempool spike. And one thing, again, we can't really talk about the intention of people because they didn't really make it well known. But at that time, a lot of the businesses had much less sophisticated processes. They were basically promising settlement times. They were often sending single payments per transaction, not batching payments. And a lot of trading still happened on basis of Bitcoin. So people that were trying to do arbitrage between exchanges were willing to pay very high fees in order to get through their transactions. Then you also have to remember that the exchange rate of Bitcoin was much lower at that time. So even if there might have been some people that had intentions of showing how limited Bitcoin's throughput was because they were trying to advertise other chains with more block space, I think that there definitely were provably people there that wanted to spend this kind of money. There was transactions going through at more than 1,000 satoshis per byte, which we've not seen since by a magnitude almost. And well, there might have been some spamming, but if it was, then it was at much lower fee rates. There might have been like the ground floor of mempool that was always maintained with like someone creating arbitrary traffic, but the stuff that happened on top of that, with the bull run happening and the exchange rate going up to 20,000, I think most of that was natural.
Okay, maybe I'm being distorted.
Okay, let's have another question, and then we have to.
Thank you, Merch.
Advance to the next speaker. Someone's coming up. Yep.
I do this from here? Or?
Yeah.
Hey, so regarding the mempool policy changes, I mean, I've never bothered trying to do any configurations and stuff with any of the nodes policies, but from your regard, do you think the security implications of having like lots of nodes with different policies is actually better than having sort of a uniform, correct one across everything as the default standard? So I just kind of rely on the default standard for the mempool policy. So.
Yeah, I think the default is the vast majority of nodes on the network because Bitcoin Core is the vast majority. And from what I hear, people don't really configure. I think if you're a wallet developer, application, or L2 developer, I would try to test against the default and make sure you're not failing that. And because I think in most cases, hopefully there will be a path from your node to a miner where all the nodes are doing default. And that's how your transaction will propagate there. But there's no guarantees, of course. And, you know, I personally prefer if people, okay, actually, no. I think it's easier to reason about the network as an application developer if most nodes run the same thing. Hopefully that's the case. I'm not sure if that answered your question.
Hopefully,
but
more, like, generally, if everybody has like different policies for this stuff, I mean, is it going to, any idea about the level of when like the network will break essentially, will not be able to get certain transactions through and things? You know, it's like, I guess it's a chicken and egg of how many nodes are on the network, or how much policy differential there is, and when that is going to start causing effects, basically. Or just keep it to say the default is alright, or have like a set number of different policies that people can choose from, and then, you know, sort of hope for the best that the numbers kind of add up. So, but,
yeah, that's
I'd like to
interesting.
more different policies myself, I think. That's the idea. Cheers.
Thank you.
Okay, that was the last question. We're going to advance to our next speakers. Thank you very much, Gloria, for joining us.
Thank you. Thank you for having me.